Hello and welcome to this lesson on simultaneous equations. So today we'll be showing you how to solve simultaneous equations by a method of elimination. The three main steps to elimination are labeling, multiplying, and then finally eliminating. So let's start by labeling up our equations. We always label simultaneous equations because it allows us to reference them easily. Instead of saying 6x plus 5y equals 39 all the time, I can just reference it as equation 1. So I'm going to call this one equation 1 and this one equation 2. Okay, the next step is to deal with our multiplication. So for this, we're going to have to learn a little bit about coefficients. Coefficients are essentially the number before your letter in algebra. So if I give you some examples to show you what coefficients are, 6x, the coefficient of 6x is 6, the coefficient of minus 2y is minus 2, the coefficient of minus 3x is minus 3, and the coefficient of 8a is 8. Now that we know what coefficients are, we need to make sure that our coefficients are actually the same so that we can eliminate them. So we can either choose to work with x's or y's. Looking at the equation, we could work both ways. So let's do x's. We've got 6x and we've got 2x. We want the coefficients to be the same. So looking at it, I could multiply equation 2 by 3, and that would actually give me 6x. So the coefficients would both be 6. So let's do that. So multiplying equation 2 by 3, I get 6x plus 9y equals 51. Okay, so I'm going to call this one equation 3. Equation 3 is just basically equation 2, but multiplied by a factor of 3. So the one that's left over is equation 1. So I'm going to write equation 1 back down here. 6x plus 5y equals 39. Okay. So what we can do now is actually eliminate. So I'm going to put a subtract sign here, do this, and then I'm going to take away. So 6x take away 6x is nothing. 9y take away 5y is 4y. And then 51 take away 39 is 12. Now I've got 4y equals 12. Nice and easy. So how do I get y by itself? Well, the thing that's stopping me from having the y by itself is actually the 4. Remember that 4y actually means 4 times y. So that means we have to do the opposite to get rid of it. So we're going to divide by 4 on both sides. And that leaves us with y equals 3. We know that y equals 3. Now anytime I see a y, I'm going to substitute it for 3. So equation 1 was 6x plus 5y. So 6x plus 5 times 3, remember this bracket notation means times, equals 39. Okay, so that means 6x plus 15 equals 39. Okay. We've got this simple linear equation now. So remember what we need to do. We want to get x on its own. What's stopping us? Well, we've got a big plus 15 there. So let's take away 15 from both sides to get rid of it. So that leaves us with 6x equals 24. Again, what's stopping us from getting x on its own? It's the 6 in front of the x. Remember that 6x equals 6 times x. So we need to divide by 6 on both sides to get the answer. So that means x equals 4. We've solved our simultaneous equation. Y equals 3, x equals 4. Let's try another question. A minus 2b equals minus 2, 2a plus 3b equals 10. First step is always to label our equations. So number 1 and number 2. Now our next step is to multiply. So we want our coefficients to be the same on either a's or b's. Now a's would be quite simple. If we did a's, we'd just have to times equation 1 by 2. And that would give us 2a minus 4b equals minus 4. But let's pick the slightly trickier one this time. Let's go harder. So instead of choosing a's, I'm going to choose b's because it's going to be more of a challenge. Okay, looking at the b's, we've got minus 2b and we have got 3b. I can tell that the common factor between them is actually 6. If I multiply equation 1 by 3 and equation 2 by 2, I'm going to get 6b. Okay, so let's do it. So doing equation 1 first, it's going to be 3a minus 6b equals minus 6. And then equation 2 will become 4a plus 6b equals 20. Okay, the reason why I've chosen to pick the b's this time is because we've got a minus b and we've got a plus. We've got two signs that are opposites. There is a little acronym that you should know. Same signs, subtract. And then opposite signs, add. Okay, so if I bring you back up to the question that we just completed, could you see that we had the same signs here? We had 6x and 6x. That's why I subtracted. Looking at this one, I've got minus 6b plus 6b. These are opposite signs. I need to add. So when I'm doing my little elimination, I now know, because of our special acronym, we can add. So that means we add them. So minus 6b add 6b is 0b. So that's going to be gone away. 3a plus 4a is 7a. And then minus 6 add 20 is 14. So now I've got 7a equals 14. Well, what's stopping us from having a on its own? It's the 7. So it's going to be a equals 2 because I've divided by 7 on both sides. Knowing that a equals 2, I'm going to substitute into equation 1. So that is 2 minus 2b equals minus 2. Okay, so I don't like having minus algebra signs. So this is something we covered in a previous video. So I'm going to move the minus 2b to the right side so that it becomes positive. So on the left side, I'm left with 2 equals minus 2 plus 2b. Okay, what's stopping us from having b on its own? Well, we've got a minus 2, so let's deal with that. I'm going to add 2 to both sides. 4 equals 2b. And then again, what's stopping us from having b on its own? Well, it's the 2 in front of it. And you should know by now that 2b is actually 2 times b, so I need to divide by 2 on both sides. So that becomes b equals 2. We've solved the equation. A equals 2 and b equals 2. Perfect. We couldn't finish this video without a nice exam question. So the eagle-eyed among you might notice that this question is actually the same question as I chose for the substitution video, because I want to show you that you can actually solve questions using substitution or elimination, and we'll put out a separate video showing you in which cases it might be better to use one or the other. But in this case, I want to show you that it's possible to do it either way. So this is the Manchester Grammar School 11 Plus paper 2016. Rachel buys 3 identical bags of sweets and 5 cans of drink. The total cost of these items came to £4.90. Rosie buys just 1 bag of sweets and 3 cans of drink and pays £2.70. So as covered in our previous video, we have 2 separate statements here, and that means we can write 2 separate equations, one for Rachel and one for Rosie. So let's get started. So for Rachel and then for Rosie. So for Rachel, she buys 3 bags of sweets and 5 cans of drink. If we call sweets S and drinks D, we can call this 3S plus 5D equals £4.90. And similarly for Rosie, S plus 3D equals £2.70. Okay, so remember for our elimination, we want to label our equations first. 1 and 2. Okay, so we want to make sure that the coefficients for one of our variables is the same. Looking at this, which variable would you choose? Well, S is actually easier because we only have to multiply equation 2 by 3. But you could technically make the D's the same as well. So you could multiply equation 1 by 3 and equation 2 by 5, and that would give you 15D. But let's do it the slightly simpler way this time. If you have time after this video, I'd encourage you to try it by getting the D's the same, just for practice. So we're multiplying equation 2 by 3, so that gives us 3S plus 9D equals £8.10. And then we've got our equation 1 as normal. 3s plus 5d equals £4.90. We've got same signs here. Can you see 3s and 3s are both positive? So remember, same sign subtract, SSS. So we're subtracting. 3s take away 3s is 0. 9d take away 5d is 4d. And £8.10 take away £4.90 is £3.20. So now we want the d on its own. What's stopping us from having d on its own? Well, it's the 4. And remember, 4d is actually 4 times d, so we are dividing by 4 on both sides. So that gives us d equals 0.8, which is 80p. So we know a drink is 80p. So now all we do is we pick an equation and we substitute into. So substituting into equation, I'm going to pick 2. Anytime I see a d, I'll write 0.80. So I'm going to do s plus 3 bracket 0.8 equals £2.70. So that gives us s plus £2.40 equals £2.70. So what's stopping us from having s on its own? It's the £2.40. So we're taking away £2.40 from both sides. S equals 0.30, which is 30p. And then we'll just underline our answers to finish. So I hope that this video on elimination has been really helpful for you and that you can get practicing with doing some questions on elimination. Our final video on simultaneous equations will teach you in which situations you might want to use elimination and which situations you might want to use substitution. So keep practicing, and I really hope you've enjoyed the video today.